Welcome to Lesson 2, Arduino's multiple LEDs. We're going to be putting on a breadboard multiple LEDs, and we're going to review the concept of looping and introduce the concept of arrays. Again, we're using our Arduino open source microcontroller for the work of this. So we'll do a quick review, and then we'll get into doing some programming. These green objects are called LEDs. What's the longer leg of the LED? It's the anode, or the positive. Here it is, longer legs positive, negatives cathode, so positive anode, cathode. LEDs are very sensitive to polarity, so make sure you hook up the positive to the battery or power source or to your pin in this case. And then there's your resistor, and there's a ground. We're sharing the grounds. What are these called? Resistors. And what do the resistors do? Resistors use limit voltage and current. Why do we connect these to the LEDs? Well, basically because LEDs don't require much power, and if you run it without a resistor, you're going to fry the LED. All right. Quickly, just trying to define. Pardon me. Quickly, let's try to define the different parts of this breadboard. So, what is part A? Where's digital pins? Where's the analog pin? Where's the power pin? So outlet shell at megachip is C. Digital pins are D. Analog pins are B. Power pins are A. There they are. Remember, at megachip is the brains of this microcontroller. Coding review, /*, */ or //. What does it do? Well, it allows you to write comments to you as the programmer, and /* allows you to do multiple lines. // is just for one line of comments. If you're going to do a paragraph, you want to do /* and then finish it with //. All right. Single line comment, multi-line comment. What about are these? What do the purpose of these brackets serve in your code? All right, we kind of refer to those as containers. They hold the function's code. So, you know, it really, in our case, you see void loop, you don't even really use it. But you're going to be using it on some for loops and different things, all right? Now, let's create a variable. For example, we want to create a variable named LED pin that stores the integer 12. So how do we begin? We start off in its integer, right? Because that's what the kind it is. We give it its name, correct? So LED pin integer, but we got to decide it's an integer, and an LED pin is a variable. And think of a variable as just a way to store data. In this case, it's an integer. We've told it that. And in this case, we're saying, hey, assign 11 to it. But we got to add one more thing because of sketch. We've got to add a semicolon. Good to go. So put this at the ends of line of code, these container for functions, and single comments and multi-line comments. Hardware assembly, we're going to need several of the LEDs. We're going to do a real quick, just a quick review of the first one we did. See, there was the first LED connected to pin 13, and we had a ground. The resistor went right over the ground. The resistor was 333. And this was the code. We defined LED pin 13 as LED pin for pin 13. We made it an output, and then we made it high or low, waiting a second in between. So it would look like a bit. Now let's do two LEDs. Something like this. And ground. There we are. in this case, we had our first say LED, right, ground. Well, now we do pin 10, it comes up, it's doing the second LED. Notice we both share the same ground right here, that blue line. All right, pin 10, pin 9. So you're programming it. Remember when we did real quick on first pin, we defined the pin, a variable that we were going to assign to the pins. We made the outputs, and then the actual action of this, where we did a display write, delay, display write, delay. Well, in this case, if we want to do two LEDs, one way we could approach this is we do integer LED pin equals 10. Integer LED pin equals 9. So we've got 2 there. Well, if we're going to have 2 there, we're going to need 2 outputs. So there's a second output. And then finally, we're going to have to do display write LED pin 1 high, display write LED pin 2 high, delay 1000, do them both low. Now, that's fine, but we're looking at lots of LEDs now. So what do we do there? Now, what we're going to do now is a little more advanced programming. And if you've had no programming before and you really like the hardware side, you might go on to a couple hardware, but then come back. Ultimately, you need to go through this. You need to understand loops and arrays. But this is a warning, a little more challenging programming. If you've done no programming before it, you might just take your time, go through it once or twice, and it'll make more sense. Okay? So first hardware assembly, we're going to put all the LEDs in, starting at pin 2. So we're at pin 2, pin 3, pin 4, pin 5. We're going to all these LEDs, and pin 6, pin 7, pin 9, and we're sharing grounds. We're using our 330 ohm resistors. Pretty much just keep expanding on what we've been doing. So there we are. We're going from pin 2 to pin 9. And we're really sharing this ground. The positive really in this is not doing very much. So we're just sharing the ground there. All right. We have turned pins 9 and 10 on. Remember, and then we did both, when we were doing a 2 LED before we go on to multiple, we said, hey, pin 1 and 2, turn both on, make them both outputs, make them high and low. And we could start that with 3 LEDs, but imagine doing that with 8 of these. I mean, it just gets to be too long. I can't imagine having to define every one of those variables like that. So before we do that, let's do a quick review of loops and review for those who've had Scratch, review kind of a Scratch loop. So when I click on that flag, I set the counter to count to 0. Then randomly I pick how many times this loop is going to repeat, from 1 to 10 times. And then every time it loops through, it's going to say change count by +1. And then at the end say count. So if it loops through 4 times, it'll end up saying 4. What that's really saying is every time it goes through that loop, that in between that repeat, pick a random number down to change count by 1, it goes through all that, and then when it's finished, it says say count for 9 seconds, but that only does it outside the loop. So in that repeat loop, what it's basically saying is assign count. You imagine if you saw count equals count plus 1. The way a computer reads that is count is 0, okay, then 0 plus 1 is 1, count is now 1. Next time it loops through, count is 1 plus 1, assign it to count, so now count is 2. So in a computer, you're going to see this with the code. It kind of it ways you to loop through and advance a value. So in this case, we're going to have a variable called counter. Oftentimes you'll see this is I, but right now, let's just say counter so we better understand. We set it initially to 0. It says what it will do then is it will loop, advance by 1, and then print something. It'll start off at 0, print something, then advance by 1. If it's less than 10, it'll go down and print it again. It'll keep doing that over and over in this for counter. This for loop, I should say. So you have counter equals 0. It's less than 10. So you're going to go through this, and it's going to print out. I want you to think about it. Starting at 0, and it can't go up to 10. So what's it going to print out? It's going to print out 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's it. Because think of integer does not have decimal points. All right. So let's employ a loop to save us work. And that should not be an employee. That should be let's employ a loop. All right. Let me do this. Okay. Let's employ a loop to save us work, okay? Now, once we have that, so here we go. We're going to say for integer counter equals 2, because we're starting at pin 2. We're not pin 0 and 1. Just start at 2. 2, counter is less than 10. So again, every time it comes through, it'll start off the first time 2, pin mode 2. The way the computer's going to read that line down there, it's going to say pin mode 2 is an output. Then it's going to go up and add 1 to the counter. And then it comes down the function and it checks to see is it less than 10. Yes, it is. Goes down and says pin mode 3 is an output. And it adds 1, goes up. Is pin 4 less than 10? Well, yes, it is. Then pin mode 4, comma, output. And we're going to do that all the way through 9. So that saves you from doing that, just to be in that. All right, the simple, nice couple lines of code. This is lots of lines of code. Now, so there's your void setup. Well, how do we make it loop so it actually makes it brighter and lower? For integer counter, and that needs a parentheses right there. Let me go ahead and drop that. There we go. There we go, right down there. All right. Now, what we're saying is for integer counter equals 2, go until counter is less than 10 and increase it each time. So the next line down says display right to high. Add 1 to that. 3. Is 3 less than counter of 10? Yes. Go down. Display right 3 is high. Add counter to it. Display right 4 is high. And it's going to keep doing that until it gets to less than 10. The minute it equals 10, it'll stop. It's going to delay a second every time it goes through that. All right. Then, so let me go ahead and do it this way. So there it is, less than 10, digital right counter high, delay 1 second. It only does that once the loop is done. It delays a second. Then this loop does it, and it sets everything to low and delays a second again. All right, so that's basic of how you would use a loop to do both turn all the colors on and then wait a second and turn all the colors off. All LED pins between 2 and 9. And that beats this all to heck. Because if we didn't do it with the loop, we'd have to take 2 pages to write all that. All right? So this is much easier than that. And by the way, this is called a for loop because it says for. All right? Now, if you just want to stop at loops now, you're good. And we're going to talk about what's called pulse width modulation. And we're going to show you how to make one LED fade. If you want to see multiple LEDs, that's when we're going to get into arrays. All right, so if you just want to learn how to do loops, just get the lights bright, either on or off, you're good at this point. Now, let's talk about if you want to make it fade. In that, we use something called pulse width modulation to fool our eyes into seeing an LED fade. All right? And only certain pins do this. And what we mean by pulse width modulation and fade is when a computer runs, it runs on a cycle. It's so many times per second. And when we have this when we say something 100% duty cycle, it's totally on the whole time. When it's 60% on, some of the time it's not on, right? By the time you get down to 20%, it's barely on. Our eye perceives that at 20% as it being low and 100% being very bright. So it almost makes your digital pin look kind of like an analog pin. You can make it dim or you can brighten it up. Remember we said it was digital, it's either on or it's off. So this is a clever way to make a digital pin look a little more analog. All right. So this, again, we're blowing this up so you can see it, that when it's 5 volts, that's not the important part. The point is it's on full blast this whole time. At this point, there's a significant amount of time during the duty cycle, it's set back down to 0 volts. There's no value. So it's going high to 5 all the way across up here. Here it's high to 5, back down to 0, and then back. And it's just little spikes. Well, this is going to look dim to our eyes compared to that being very bright. And on a red board, there it is. These pins, you can see them right here. 3, 5, 6. And these are true on an Uno. Even though if you go to use this, if I simulate this, it doesn't show those little tithe marks here on 3, 5, and 6. But they are indeed there. And it kind of refers to them here. On a normal Uno, you can see that. All right. All right. Now, what we're going to do next is we're going to, first of all, hook this up so you can disconnect some of your pins, what you had running, where you had all these hooked up. You're going to go from 3 to 5, 6, 9, 10, 11. And then you need a ground. And then you have your LEDs connected to your resistors. Okay? Take a minute, make sure you build this. Now, we're just going to take one pin and we're going to fade it. We're going to brighten it up and then we're going to fade it. So we're going to do void setup, pin mode 3, that's the one we're going to use, output. Now, we could have made a variable in here, but to fit it on the screen, I didn't. I could have had, integer LED pin, make it 3, equal 3, semicolon. But we're not going to do that in this case. We're just simply giving the number. So then, should be pretty familiar. This part of the code should be pretty familiar with you. Whoops. This bit of code right here should be somewhat familiar. Now we're getting a void loop, and this is where we're starting to use our loops again. For integer counter equals 0. Do this until counter is greater than 2, equal to or greater than 256. So as soon as it gets to equal 256, it's going to stop. We're now using a new command. We've been saying analog write. Now we're going to say we've been saying digital write. We're now going to say analog write. So this is analog write, parentheses 3, comma counter, parentheses semicolon. And then we're going to delay 5 seconds. So what this is saying is, pin 3, display write, would say it asks for a pin and how much power you want to supply to it. And the power and pulse width modulation goes from 0 to 255. So the first time through it's going to be 0, and then as it loops it'll be 1, then 2, then 3, then 4, all the way up to 255. It's going to wait. As it does this, to slow it down, it's going to have a delay of 5 seconds. Then it's going to say for integer. And actually, this is going to do it a little bit slower. You could speed this up, and you can play with these delays on this a little bit. For integer counter 255, counter is equal to or less than 0. So in other words, equal to or greater than 0. So you start high, you're going to go low. In the case where we went up, it's counter plus plus. In the case we go down, it's counter minus minus. You have analog write, 3 counter, delay 5 seconds, and delay 1,000. And so it'll zoom up, and then it's going to zoom back down. All right? And now, what if you wanted to make them all look like they're breathing? We need to learn the concept of arrays. All right, so if you want to stay for a little bit on arrays, here we go. All right, if we use Scratch, we can make in there, they call them lists, but they're basically arrays. And we made a list called cheers, show list cheers. We can add hooray to the list. We can add you can do it to cheers, you're amazed, cheers, all right, cheers, that's equivalent to cheers 4, this is 5. And then, so what would this one be and this one? If cheers 5 is this one, if cheers 4 is this one, cheers 3, cheers 2, cheers 1. Look, they all share the name of cheers, but we need to be able to specify which one. So when we say cheers 2, all right, list item 2, so we know that is cheers 2. List item, that's the first item in the list, all right? Or cheers 1, this is cheers 3. This is cheers 4. All right, so that's the fourth item in the list. There we go. All right, and the first command up here just showed all of that. All right, so that allows us then to do things like be able to say anything off that list, be able to delete all of everything out of these list of variables so it comes off this table. You don't even have to show this, by the way, when you run the program. But I did that to give you an idea that a list is a list or an array. An array is a collection of variables. It's all sharing the same name. This saves us doing a lot of code, and you can imagine with looping we can really blow through things with this, so it really helps out measurably. Each member of the array is identified by an index number. See, right there it is. If an animal is an array, then animals 2 is a member of that array. So animals is the array, then animal 2 is part of that array. Let's look on this. So we're going to start with the array index. We always start with 0, and we're going up to 7. So that will give us 8 here. 1, 2, 3, 4, 5, 6, 7, 8. All right, so my array index, there's cat. So if I had animals, parentheses, 0, parentheses, cat would be assigned to that. If I had animals, parentheses, 2 parentheses, then the bird's assigned to that. And so forth. Okay? So let me ask you a couple questions. What animal is animal 3? I hope you said a horse. What animal is animal 5? This is animal is the array, and this is a member in the array. 5, cow. Why does the index only go to 7? Because we only have 8 animals to add here. It goes from 0 to 7. And if you count this, we only have 1, 2, 3, 4, 5, 6, 7, 8. So 0 to 7 is the same thing as 8, and we have 8 members. Why do we always start that? Because we don't want to waste the space. Especially early computing, memory was a real premium. So if you want to keep a single place digit, because that saves you on memory, single place being 1, 2, 3, 4, double digit would be 10, 11, 12, 99, 88. Triple place would be 100, 599. You know, if you write it out, you can see how many places they have. Now, an array helps with us. So we can fill this array up, LED pins, bracket, bracket, with these members. The same members that we found with pulse width modulation. So it's integer just like we did with the regular variable, but here we have LED pins, again, could be pretty identical. It's this bracket in here, and then using these containers make it an array. So if we have 3, 5, 6, 9, 10, 11, for integer counter 0, counter less than 6, increase I by ++. So pin mode, LED pin I output. Wow, that's a mouthful. So what this does is it's going to loop. We've seen that before. For integer, counter equals 0, counter is less than 6, increase it by 1. So it's going to start off with 0. Pin mode, LED pin, since the first time through I is 0, that's going to be the same thing as I. Well, pin 0 on this one is 3. So that's the same thing as instead of saying LED pins bracket 0 bracket, you're saying it's the equivalent of 3, because that's how we define it up here. We make that an output. Then the next one, it's going to say, well, what is LED pins I? It comes back up the loop. We add a numbered I. So now it goes from 0 up here to 1. I know it's got a value of 3, but we're talking about the member in this array. So 0, 1, 2, 3, 4, 5. So when I say LED pins bracket, excuse me, you're really telling the computer says, oh, I'm looking for the 6th member of the array, and that array member is 11. So we're able to put that all as an output, and don't worry if you don't get it quite off the bat. This is a fairly complicated topic. All right, you just have to work out a little bit. So in this case, I have a for loop. For integer I equals 0 to I less than 256, analog write LED pins counter I. So this time, where last time I would tell it a value, this time I's changing, but so is the value. So last time we had like LED pins, comma I, and then they would change every time through. And this time we're saying, whoa, 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 whoa. We're going to start with counter 0. We're going to apply this to that LED, which in this case is going to be number 1 on that. And then we can look up here on an array, that's value 3. Then as it loops through again, it'll be the 2nd member in the array, which is 5, and then 6. So we're using 2 variables in this case. Counter, right, and then I. Because we defined LED pins as array member. That's what that is. When then we put in the parentheses counter. Counter is a 0, so that's giving the different indexes, the different spot on the array. And then I is the value for the analog write, which we're looping through here. So you can have what we have here, and that's a loop within a loop. And then to go the other way to make it fade down, we do start with 0. We don't go any greater. All right, so we have that. For counter equals 0, counters 0 less than 6, counter is increased by 1. So again, we start with the first member of the array, so it loops through. But now we start with I at 255. I should do that until it either is greater than or equal to 0, and then it's going to subtract 1. So analog LED pins counter, comma I. And so in this case, the first time through this loop, and this is why it's a little bit confusing, first time through that's 0. So this is 0, comma I. Well, it's going to go through that entire loop 256 times, and then it's going to get out of this loop and come up here and do this inner loop 255 times, and then this outer loop, let me get my mouse to come up. This outer loop will go to 1, which is still less than 6. Then it'll come through. This inner loop will go 256 times. We're going to keep doing that over and over again until the counter gets 6. Okay, that gives you a really cool suite of how to do this, and it really gives you a neat effect. So I would go ahead and try this, play around. The first time through, if you've not done a lot of programming, just get to the point of the loops, stop, do the loops, stop, hold off in the array. When you do come in the array, take your time and redo it. But arrays are a very powerful programming tool, and every programmer should learn how to use them. All right? Hope you've enjoyed this webinar, and I hope you found it useful.